Hey, I'm Sophia.
And I'm Sanjana.
And we're the SS Science.
Get ready to sail with us
through a sea of scientific knowledge.
Hi everybody, today we're going to be learning about osmosis through a cool gummy bear experiment.
Okay guys, so for this experiment all you need is a cup, some water, and a gummy bear. Alright, so what you want to do is you just want to pour some water into your cup. And then you just want to plop your gummy bear right in there. You check on it every now and then because this takes a little bit.
If you watch closely, you'll be able to see the gummy bears expanding over time. See if you can form a hypothesis as to why the gummy bear is expanding. If it's helpful, go back to the beginning of this time lapse to compare the size of the gummy bear at first versus its size now.
So why did the gummy bear get so huge?
That would be the work of osmosis. Osmosis just describes the motion of water through a semi-permeable membrane into a solution that has more solute than solvent. Osmosis will continue to happen until the concentration of water inside the solution matches the concentration on the outside.
Okay, that was a lot of science. I'm not sure I completely understand yet.
And that's perfectly okay. There were a lot of big fancy words in there. Let's use our gummy bear experiment to help us define what's happening with osmosis. Okay. For osmosis to happen, you need water, which we have in the cup, and you need a solution, which would be our gummy bear. In science, a solution just describes any mixture between two or more substances. In our gummy bear, for instance, there are at least two substances, such as gelatin and sugar. Now here's where osmosis actually happens. If you note in the beginning, we have a cup that's full of water and a gummy bear that has very little, if any, water inside of it. When we plop the gummy bear inside the water and wait a few hours, the gummy bear inflates because it's full of water now.
But why is the gummy bear full of water?
Well, that is osmosis. Yes. Osmosis just kind of happens. If it can happen, it will. If you have water and you put a substance that doesn't have a lot of water in it, if water can get into the substance, then it will.
Okay, that makes sense, but I put a marble in a glass of water once and nothing seemed to happen to it.
That's because the marble isn't permeable. It isn't made of a permeable material. A permeable material is a material that gas or liquids can get through. For instance, if you put your shirt up to your nose, you can still breathe through your shirt. That's because your shirt is made of a permeable material. The reason, however, you're told not to put a plastic bag over your head is because plastic is not permeable, air can't get through, and you'll suffocate.
Okay, so does osmosis only work with water, or does it work with other liquids too?
When people talk about osmosis, particularly in a scientific setting, they are just talking about water.
Okay. So once I heard my teacher say the word isotonic, what exactly does that word mean?
Well, actually, there are three words you need to look out for: isotonic, hypotonic, and hypertonic. They each describe the balance of solute to water in a substance. If you remember earlier, I said that osmosis occurs until the concentration of water inside a substance is equivalent to the concentration on the outside. Now, an isotonic solution has the same concentration of water inside the substance as it does outside. That would be like our gummy bear after a few hours into our experiment.
I see.
Now, a hypotonic, HYPO, solution describes our gummy bear right at the beginning, where it didn't have any water in it. A hypotonic solution just describes a solution that has more solute than solvent in it. If you put it in a body of water, water will go into the substance. So a hypertonic solution describes a solution that has more water inside of it than its surroundings. So this would be our gummy bear right towards the end of the experiment. If we took it out of the water and then just put it on our counter, it would start leaking water. And this is also osmosis.
Okay, so if I left the gummy bear in the water cup, would it just continue to absorb water until there was no water left?
No, it would not. Now, using the terms that we just learned, our gummy bear in the beginning is hypotonic, which means that it has more solute in it than solvent. When we put it in the water, it would continue absorbing water until it was isotonic, or until the amount of, or the concentration of water in the gummy bear was equivalent to the concentration of water outside the gummy bear.
Oh, I see. Well, thanks.
Yeah, anytime. I hope you learned something.
I did.
And I hope you learned something too.
Sure. Thank you for voyaging with us on the SS Science.
We hope you had fun learning.